What's up, YouTube? We're going to do a take two because I had a mistake the first time I tried recording this video. It was only a couple minutes worth. It wasn't that bad. Anyway, what we're doing here today is I wanted to give an update on my Nitrous project that I'm putting together. This is, I'm sure if you followed my other videos, you've seen me ramble about this car for God knows how long now, but it's my 1984 Corvette. Well, most of it's a 1984. I've got an LQ9 in here that I've built with T stage 2 heads, Summit cam, fast intake, yada, 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 4L80E trans, Dana 44 rear end. And you might be wondering, I mean, it's Father's Day today, and you can see it's a gorgeous day out. Why am I not out doing burnouts and, having fun in the car? And that would be because I can't get the stinking thing aligned. I put in new steel half shafts and rebuilt the rear suspension over the winter, which obviously would require a rear end alignment. I also did the van steel tow rod assembly in the back, and I can't get a shop to align it. Everybody's that could do it is on a waiting list, or are so backed up that they can't get me in here locally. So I'm trying to investigate some other options, but I'm literally waiting to get the thing aligned. I can't find a shop that's willing to do it with that aftermarket tow rod assembly in there. So, but that's not why I'm making a video today. I wanted to make a video as an update to the nitrous oxide that I've been working on in this car for freaking ever. And I'm just starting to get the plumbing and things wrapped up. I've got some really unique stuff that I've never seen on another car ever that I've done on this thing. And I want to talk about that and kind of how I did it on a budget. But the idea is this engine is run by Holley management. I have the Holley Terminator X Max, and you can see the little touchscreen right there in my incredibly dusty car. And that runs all the engine management and the transmission and all that. And I'm having the Holley control progressive nitrous oxide. And you can see here the way I'm doing that, if I move my light out of the way, is a direct port fogger. And I've plumbed all this in. I've bent all these lines myself, but I have just a single, you're not going to be able to see them. I talk about it in my other videos, but I just have a single nozzle fogger in each cylinder. So this is injecting nitrous only. It is not injecting any fuel into the engine through a solenoid. The fuel injectors take care of that part. These are 76-pound injectors from Holley that are flex fuel compatible, way bigger than what I would need just for a basic 500 horse motor, which is what this is by itself, or naturally aspirated. So you do the math on it, and I even had talked to Holley about this several times. They said that the 76-pounders would take me up to about a 70% duty cycle at 750 horse on spray. So that's about where I want to be. So that's pretty good. I could have gone a step bigger, but I didn't see the point. I didn't want to fight with idle issues going too big of an injector. So the fuel injection and the injectors are going to take care of the fuel side of the nitrous. And then I'm doing progressive direct port. And you can see I've got it plumbed on both sides. Okay, and then you can see this black hose going down. Back here is the cheater solenoid. I'm using just a single cheater solenoid that will be PWM controlled. So as the engine RPM increases, so does the nitrous oxide. Right now, the jets that are in there are only a 100 shot, because with nitrous, you got to learn to run before you can, or you got to learn to walk before you can run. So I'm going to get my fuel maps and everything dialed in on 100 shot progressive, just to get the tables in, just to get it working. I mean, honestly, how much nitrous oxide do you really need in a street car out at stoplights anyway? I don't have slicks on this thing, so, what do you want? But I'm going to get that dialed in. The motor, in theory, should be able to take quite a bit more than that. The piston rings are gapped quite a bit. So I should be able to hammer it with quite a bit of nitrous. I'd like to go up to a 250 shot eventually once I get the tables in and get the preliminary program hashed out. I want to come around to this side of the car before I get into some of the weird stuff that I'm doing for nitrous. The main focus of this video is going to be on the permissives for the nitrous to actually function. So this is just a purge solenoid. I just bought the cheapest nitrous solenoid I could find at Summit Racing was a Zex brand, ZEX, I think. But I just have it. That Holley Power Shot solenoid has a purge port on it. So I'm just coming off that purge port, right to here, and then I just have a breather on the other side. So it's just going to purge that nitrous right there on top of the exhaust, all nice and sloppy like. So that's basically it under the hood. I mean, that's cool. I mean, it looks nice. I'm really happy with how the direct port turned out. But what I want to do is talk about what I've got going on here. Now, before I show you this, understand this is an absolute mess. I am not done with the wiring. In fact, I'm only about halfway done. So please don't criticize me too much. This is my mess, but the premise is this box here, let me show you, is a speaker box. I have two 8-inch subs that work. The amp is underneath this seat. This compartment I built hides the nitrous bottle and all the components, okay? And there's a lid that goes over this that completely hides it, okay? So now you're probably wondering, what in the world am I doing with all this? Well, first off, we're gonna take a look at this bottle. Oh boy. Well, I would, but this is ridiculously difficult to do one-handed. You can't see. What I did is I took a hydraulic valve. And what I wanted is an automatic bottle opener. And I wanted a computer to be able to control that automatic bottle opener, okay? Well, I don't know if you've priced automatic bottle openers, but they're about $400, and I am way too cheap for that. So what I did is I took some hydraulic fittings, and these are all just hand fit and loose. I took a 3000 PSI hydraulic valve, and I welded together an adapter up here at the top, and I bolted a window motor out of a Suzuki, I don't know, some front-wheel drive POS. And it does a very good job of controlling that valve with that motor. Then I took this blue thing here, is a small inductive proc switch, and there's a tab of metal that whenever that valve is all the way closed, it activates that proc switch. Okay, so that way the PLC, or the controller I'm going to use to run it, knows when the valve is all the way closed. Okay, so I get feedback to a computer saying the bottle is open or closed. This wire you see dangling here, this is actually a temp sensor for an electric dryer. The reason I put this in here is that's a really low temperature. I think it's like 100 Celsius, or no, it's way lower than that. It might be 80 Celsius or something. But it's the lowest one I could find, and that's if there was some kind of a failure, because there's going to be a bottle blanket on this to heat up the bottle. If there was some type of an over temperature condition, it would pick up on it, okay? Moving on, and again, this wiring is not cleaned up. This is a ProSense pressure switch. I'm going to be using this simply to send a signal. Is there pressure in the line, yes or no? So this would be pressure after the bottle valve. Okay, so is there pressure in the line, yes or no? So if you think about it, the bottle could be closed and there still be pressure in the line. This sensor will say whether there's pressure in the line or not. And I think I have it set to 200 or 300 PSI. I mean, you don't need it to read exact pressure, just something. It's just a yes or no. Down here, though, this is an actual pressure sensor, also a ProSense. I don't have it finished wired in yet. This is for analog inputs, but this sends out a 0 to 10 volt signal that gives you exact pressure from 0 to 1500 PSI. So really right where you'd need it to be for nitrous oxide, that actually works really well. And then I have a little relay block down here to wire the whole thing. Okay, so you might be asking, like, why do I got all this crap? What's all this being fed to? I'm not using the Holley ECU for all these sensors. No, I'm using this. Again, wiring is a mess because I'm still in the testing setup. This is a Click PLC made by a company called Koyo out of Japan. They are refined, and the software to program them was made out of an office from Automation Direct in Texas. They aren't necessarily built for automotive use, but they work unbelievably well for that purpose. The only downside to these is they are 24 volt DC only, because it's an industrial controller. They're not meant for use in a car. So what I have down here is a buck board that takes, a boost board. So this would be a boost power supply. This takes 24 volt DC in, steps it up to 24 DC out. So that powers the PLC. Okay, so let me break down what else is going on here. You can probably see this guy. This is a little HMI. I did a little video on this before where in one of my other videos about how I programmed this and got it to work. This gives me 5 push buttons for my control of my nitrous oxide. It also gives me alarms. It tells me bottle pressure. It tells me all the permissives that are being made or not. So this gives me all the feedback. This will eventually be installed right here in the area that would normally be for the power seat control that I don't use anymore because I ripped the power seats out and now it just collects change. So that's where this will be going. I'll get to what these are here in a second. These aren't actually going to be installed in the car. This guy. Okay, so I wanted accurate temperature. This is a PT100 thermocouple. And the reason I'm doing this is I'm going to take that thermocouple and it's going to lay right on that bottle, and then the bottle blanket's going to be wrapped around it. So that way I will know the temperature of the surface of the bottle, just so that way I'm not over temping it. And I have programmed into this guy that if the temperature exceeds a certain point, that the bottle, it'll shut the bottle blanket off. So if it's being that it's all enclosed and I can't see it, it just made me feel better to have some type of thermal protection on there to make sure that nothing was going to catch on fire or over temp. Because I am going to use a pretty wicked bottle blanket on this thing. So I've got 2 temperature sensors. One is just a switch that's just a, oh crap, I'm too hot. And then the other one is an actual temperature that does display temp on the screen here. It will tell me the bottle temperature, the exterior bottle temperature. So you might wonder what this green deal is here. And those of you that are PLC or industrial controls gurus or even novices will wonder why in the world I did it this way. If you're unaware, thermocouples, like this guy, kind of put out a goofy signal. They don't put out a standard 0 to 10 volt or a milliamp signal. They're kind of their own thing. So the only way I could get a PLC like this to read a thermocouple would be with a thermocouple input card, which you can see on this PLC. I've got 2 different cards here, one here and one here. I could have bought a thermocouple input card that's good for, I think, 3 or 4 thermocouples. Those stinking cards are $200 a piece. This little guy is a signal conditioner that converts that thermocouple signal into a standard 0 to 10 volt analog signal, and I have a regular analog card here, which is much cheaper. This little signal conditioner is only $20. So it works exceptionally well. I tested it in my deep freezer, and it's freaking awesome. It displays temperature on the screen accurately, way more accurately than what I need it to. I got the thing off like Alibaba or something like that. It's just a cheap Chinese signal conditioner, but so far it works really, really well. Okay, now moving on, you might be wondering what these guys are. I got 2 of them here, okay? If you've never seen these before, these are not going to be installed in the car, okay? This is a PWM driver. What it does is when you power it up, it sends a pulse. So here's the idea. If you've watched my other videos, you know that this over the winter, I changed my rear hub in this car to one that can accept a wheel speed sensor. So there is a tone ring in the back of this car. I know it's an 84. 84s didn't normally have ABS or don't have ABS. This car has an ABS tone ring on the back because I installed the yokes that had the ABS rings on the back. I have not put one in the front yet because I don't have the hub for the front. I need one off of an 86 or an 87, and I just don't have one on hand right now, but that'll be next. So why would I do that? Just on the driver's side of the car. I'm not doing it on the passenger side. Why would I do that? Well, because I have inductive proc switches, and sorry to make you sick, but I think, yeah, right here. This inductive proc switch is a high-speed procs, and I've made this bracket that will fit right down inside of the hub on an 86 or 87 Corvette ABS assembly. So that way, that little inductive proc switch will see the teeth on the tone ring of that wheel as it goes down the road. There's 47 teeth on that ring on the front and the back. So what that means is if I take those 2 proc switches, both on the driver's side, and I feed them to that computer knows the speed of the car then. Simple math, you can convert it, and you can, by tire size and number of teeth, it knows the speed. More importantly, it knows the speed between the front and the rear wheels. So if I lose traction, if I break traction, that computer knows it. Okay. So why is that important? You want the computer to know when you're doing a burnout. Think about it. This is progressive nitrous. So the higher your RPM, the more and more nitrous gets poured into the engine. Okay. So if you lost traction, meaning your back tires are just spinning, your RPM is going to go through the roof, it's going to rise, and the computer is going to continually feed it more and more nitrous faster and faster. In this case, though, because it knows when there's wheel slip or wheel spin, this computer, what his job is to deal with permissives. If something isn't right, it cuts the signal to the Holley computer to tell it to shut the nitrous off. That's the whole point. So if I lose traction, it sends a signal to the Holley and says, hey, nope, shut it off. So let's go through what all does this guy do? What all is he looking for? Well, obviously traction, right? If I lose traction, it kills the signal telling it to shut off. It's also looking for temperature. Okay, so is the temperature within spec to allow it to operate? Pressure, is the bottle pressure where it needs to be? Okay, so I can't remember the exact numbers I had it set at, but the bottle pressure needs to be high enough for it to function. And then is there pressure in the line to of the actual pressurized line going to the solenoid? So all those things have to be answered yes before it sends the trigger signal to the Holley ECU to tell it that it can actually run the nitrous. Without that signal, and that's one input on the Holley, just one wire input, yes or no, is it getting that information? And then once it gets that, then it'll allow it to run. A couple other things that this does is the buttons here on the touchscreen. The first button will be to arm the system, open the bottle, close the bottle, purge, and then this one changes screens. I have two different screens on here, and this last button cycles between the different screens. So I have all my buttons that I need for the nitrous built into that HMI. I don't have to put in any push buttons or anything like that. I have them all right here on this $130 little contraption that gives me everything I need. So by the end of it, I'm trying to automate nitrous oxide. I'm trying to make it all so the computer takes over. The Holley will monitor things like RPM, throttle position, gear. I can make it exclude nitrous in certain, for anything I want there. So it has to be 90% throttle position or 95, whatever I set it at. And then certain RPM window switches all built into that. So that's about it. I got incredibly nerdy into building nitrous oxide. Figured I would share it on my YouTube channel. And I think it's turning out pretty well. But I still have a lot of wiring to go. You can see I've got power cables just dangling here. I've got to get my wiring completely cleaned up inside here and get the lid and things back on. And also too, I don't have the spindle up front yet. So the wheel speed sense is not going to be working right out the gate. I am going to get it running on nitrous and get the progressive tune started before I start messing with wheel slip. So that's about it. Like I said, I just wanted to give an update, not a crazy long video. But I just want to give an update on the car. I know I haven't made videos in quite a while, but I wanted to show you guys what I was up to. All right, catch you later.